Hi folks, here we are, 1.3 square roots and Pythagorean theorem. What we're doing in this lesson is measuring line segments. This one is kind of cool, but once we finally kind of get to the Pythagorean theorem, which is one of the main things we do in Math 8, and certainly the main thing we're going to do in this chapter, this method will be a little less relevant, but I still nevertheless think it's kind of cool and something I need to cover. So here we go. So students will use the area of a square to find the length of a line segment. So they're kind of saying if we're trying to find the length of this line right here, we can use finding the area of the square to do that. So consider the following squares. What is the area and edge length of each of them? So if we look at A, I can just count that the area is 1, 2, 3, 4, 5, 6, 7, 8, 9 square units, and the side length would be 3. If I look at B, I can just count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and I can see that the side length is 4. Side length's 4 there as well. All the side lengths are 4. So how did you find the side length of square A and B? I would say I counted. But let's look at C and D. I mean, it's kind of hard to tell. It seems like this would be 1, 2, 3, 4. And this looks like this would kind of make like a half and a half. So maybe this is 1, maybe this is 1, maybe this is 1, and maybe this is 1. So like 1, 2, 3, 4, 5, 6, 7, 8. 8 is my guess. Oops. And this one, I guess I would say we got 1, 2, 3, 4 for sure. And then, gosh, this is kind of like 3/4, 1/4. Maybe that's 1.5. So 1.5 times 4 is going to give us 6. So maybe about 10, and maybe this is about 8. So what about C and D? How did you find the edge length? Did you estimate or calculated? I estimated based on how it looked on looks. Okay, this is for side length. This is for area. Again, remember I counted. So for the side length, I could have just gone 1, 2, 3. And for the area, I could count each of the squares individually. And again, what's the area of each square? I estimated based on looks. Okay, so I kind of gave my best guess, just kind of looking at it. I don't really know if that and that would make up a perfectly covered square. This actually looks like kind of more than a half, so I don't know. I think maybe it'd be slightly over 10, maybe 11, who knows. Okay, since A and B are not rotated, it makes determining the area easy. You only need to count the small square, and the edge length is found by counting the length or width of the square. So, however, the area of square C and D are more complicated. Before we can begin, we need a quick refresher on triangular area, or the area of a triangle, so how much space a triangle takes up. So finding the area of a triangle, we have a formula. Formulas are great. It's a way of doing things the same all the time. We can always use this information. So the area of a triangle equals the base, and that case would be what our triangle is sitting on, times the height. Okay, so when we have in math brackets and they're just beside each other, it means we are multiplying. Okay, so the base times the height divided by 2. So here, the base would be 5 centimeters right there, and the height would be 10 centimeters right there, then divided by 2. 5 times 10 is 50. 50 divided by 2 is 25 centimeters squared. The reason we have to divide by 2, you can imagine it's almost like we're calculating the area of an invisible rectangle, and then we're cutting half of it off, because that would be 10 times 5 would give us the area for this whole thing. But the triangle is actually only half of that. So we can't count the whole thing. So we need to divide it by 2 because we only want that much, not that extra part right there. Okay, So example, now let's use this information, what we know that base times height divided by 2 is the area of a triangle, to find the side length of a square that is on an angle. So our first step is to create a box around the square which touches all the vertices or all the corners. So this one right here, I've done it for you, but I'll kind of outline it. So we made a square around it that touches all of the corners of the square, the vertices. Okay, notice that there are 4 triangles on the diagram, now each marked with a T below. So we got a triangle right here. We've got a triangle right here, triangle right there, and a triangle right there. Okay. To find the area of the side length of a triangle, we need to find the area of the 4 triangles. Okay. So we need to find the area of this triangle right here that there's 4 of them that I've shaded for you. So we need to do base times height times 2. Now, how can we find the base? We can count it. So this base right here, this triangle, at the bottom is taking up 1 square. So I can do 1. And the height, I can see it's taking up 2 squares. So times 2. I think I'm going to sneeze. Excuse me. So we have 1 times 2 divided by 2. So 1 times 2, everybody say it together, is 2 divided by 2. Any number divided by itself is just 1. So this triangle has an area of 1 centimeter squared. Since there are 4 triangles, the area of the triangles is 4 times 1. So remember, we determined that the area of one of these triangles is 1 centimeter squared. So since there's 1, 2, 3, 4 of them, 4 times 1 is going to give us 4 centimeters squared. So we've just found out the area, collective area of all of these shaded parts is 4 centimeters squared. Okay. Now, seems like a lot of steps, but we're good. We're going to do this. We got this. The area of the original square will be what is left when we subtract all the triangles from the large square. So we're trying to find the area of this inner square right here. Trying to find the area of that one right there. So what we are going to do is find the area of this big square that we made, remember, that touches the vertices of the smaller square, and subtract away those triangles. And what we will be left with is the area of the inner square. So remember, the area of a square is length squared. So our length of this one, we can count it, is 1, 2, 3. So 3 squared. 3 times itself, well, I usually use blue. That means 3 times 3. That's going to give us 9 centimeters squared. So we found the area of this big square. We could just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. That matches. Now we need to take the area of the triangles from the large square, or subtract the area of the triangles from the large square. So the small square equals the big square minus the triangles. So small square equals, what was our big square? Remember, we just found that it was 9 centimeters squared. And minus the triangles, remember from before, we found it was 4 centimeters squared. So the small square, therefore, 9 subtract 4 equals 5 centimeters squared. So the area is 5 centimeters squared, drawn right there. The side length of the square is, this one is tough. This might not make sense to you right now, but I promise it's going to later. So I'm just going to leave the answer as it is. And I explained it. We are going to come back to it. It means the side length is the square root of 5. So square root of 5 is not a perfect square like 4 or 7. So getting the square root is not as simple as figuring out which 2 numbers which are the same multiply to give 5. But we're going to figure out how to calculate this later. So let's just leave it as that before. One thing I guess you can know is that length squared equals area, and the square root of area equals length. So if we have the area, we don't know what the length is, we can just put a radical sign around the 5 to find the side length. This is because squaring and the radical sign or taking the square are opposite or reciprocal operations. And I think I'm explaining too much. I promise you're going to get it. You're going to be pros. So let's move on from this. So let's try another one. Here's the next example. First, draw a box around the vertices of the square. So I've got starting square here. Now this is with the square drawn around the outside. So remember, there's a square that touches all of the vertices or corners of our other square. Now we need to calculate the area of the triangles and the square. So we got to figure out the big picture here, the whole square, and we have to calculate those triangles right there. So that's our next two steps. Calculate the area of the triangles in the square. Okay, so base times height divided by 2. If we look here, the base of our triangle is 1, and the height is 1, 2, 3. That looks right. Let me erase this. I can hardly see. No, it's actually 4. Okay, so 1 and then 1, 2, 3, 4. Okay. So triangle equals 1 times blue. 1 times 4 divided by 2. The triangle equals 4 divided by 2. So that's going to be 2 centimeters squared. Or I think it's units squared. I don't think we're talking about centimeters. Oh, they're using centimeters, so let's do it. So 4 triangles is 4 times 2, so we would get 8 centimeters squared. Now we need to find the area of the large square, which is going to be length squared. So let's have a little look. Our big square right here, let's count it. 1, 2, 3, 4, 5. Okay, so our length is 5. So the area of the big square is going to be 5 squared. Remember, 5 times, that's a 2. 5 is going to give us 25 centimeters squared. Our last step to find the area of the small square, we need to minus this from this. So let's go 25 centimeters squared minus 8 centimeters squared. Actually, I think what I was supposed to write there was minus the large square minus triangles. Hope you can read that. That would be 25 minus 8. And you are left with 17 centimeters squared. Side length of the small square is the square root of 17 centimeters squared, or radical sign 17 centimeters. Okay, let's do another example. I might run out of time soon on our video, but I can make another one. What is the area of the side lengths of square C? So the first thing we need to do, but it's already done for us, is make a square along the outside. I already did that. Now we need to find the area of the 4 triangles. So triangle, remember, is base times height divided by 2. The base in this one is 2. The height is 2 as well. So you got 2 times 2 divided by 2. That leaves us with 4 over 2. So the area of the triangle is 2 centimeters squared. And since there's 4 of them, we need to times the 2 by 4. And we get 2 times 4 equals 8 centimeters squared. Now let's find the area of the large square. So we can just count the side lengths. The area of the square equals length squared. So we can count 1, 2, 3, 4. That'd be 4 squared. The area of the square is 16 centimeters squared. To find the area of the small square equals the large square minus the triangle